Okay, example 8 is similar to the problem that we did where we had to make groups of basketball players with men and women, except here we have to make committees with people who said yes and people who said no. So I hope that you guys are seeing the similarities, and that's what you're going to have to do on a test or a quiz. Just identify which problem your test question is similar to and do the same kind of strategy. So in this case, for the first part of the problem, it said how many committees of 6 can be made, regardless of what they decided, whether it's a yes or a no. In this case, we had 40 members in the initial club. There's 40 total, and we want to select basically 6. So 40 choose 6, and you get the total right there, 3 million roughly. Now, the second part of the problem is asking for how many of the committees will contain at least 3 club members who said yes in the first vote or whatever. So to say that you have at least 3 members who said yes means you have 3 who said yes, or you have 4 that said yes, or 5 that said yes, or 6 that said yes on your committee. So it's easier to count each one of those committees separately. That's why I did it this way. Okay. Now, how many people said exactly, and how many committees can there be where 3 of the people on the committee said yes? Well, what I have to do is basically select 3 out of the 24 that said yes, and then fill the last 3 positions with the people that said no. That's the reason why I'm writing the way I'm writing it. Okay, so again, keep in mind, these bottom numbers always add up to the size of the committee or the size of the basketball team, which is in this case 6. And the numbers on top are basically your men versus women, or your yeses versus nos in this case. And we did that multiple times, for the other committees. And the tally adds up to roughly, again, 3 million. Okay, so that's the end of example 8. So that should remind you of the problem where we did basketball teams with men versus women. Okay, example 9 should remind you of the Mississippi problem. And again, it looks pretty much the same. You've got the word and you've got multiple repeats. In section 9.1, we did sort of similar problems. I don't remember if it was 9.1 or 9.2, but we had the word computer, we had the word bytes. The difference between those words and the words that you're seeing in this section is that in the word computer, none of the letters are repeating. In the word bytes, same thing again. However, in the word Mississippi or millimicron, you have a lot of repeating letters. So that's kind of what I do first. I tally up the letters and figure out what the total is. And I use my formula, my rule, to figure out how many possible reorderings there are. Now, parts 2 and parts 3 are a little bit tricky because in this part 2, it says we want the words to begin with the letter R and to end with the letter N. So I'm kind of writing that a word starting with the letter R and ending with the letter N is kind of like quote unquote the same as a word without the letters R or N. Since they go at the beginning and at the end, and in the middle you can put whatever you want, just ignore the R, ignore the N, and you get a brand new word, and figure out what the word is. Then just remember that it starts with R and N. That's kind of like why I'm saying it's sort of quote unquote the same. Okay. And if I ignore the letters R and N, then I get a new tally. My numbers or my letters, there's 2 M's, 3 I's, and so on. So there's a total of 9 characters or 9 letters. And again, I get the total using my formula. Now in part 3, we're thinking of CR being next to one another in that order always, or ON being in that order next to each other always. So what I'm saying here is I'm saying think of CR as now being one letter. Instead of 2, think of it as one unit. It goes together always like that, or ON goes together as a unit always like that. So if we think of it as one unit, then we have only one CR and we have only one ON. And again, the total is going to be 2 plus 3 plus 2 plus 1 plus 1, which is 9. And using the formula, we get the amount of words. So that's it, pretty much. That's the end of the section.